Hello class, if things go well, you'll be able to view this video before our Thursday class, September 3rd. In any case, I hope you'll watch it before we come back after Labor Day. So this is the fourth video that I've tried to record. Well, we had a problem on Tuesday. I posted the link for the Zoom meeting as a Blackboard announcement, thinking that you would go there and get the link, but you were, I guess, used to seeing the link delivered to you as an email, and so we had to cancel class Tuesday. That's mostly my fault. I regret it happening, but we can deal with it. I mean, it comes at a good time because the long holiday weekend is coming up. I can make this video and maybe even another one. And I also think we should move the date for the first test. We certainly won't have it on the 10th of September. That would be Thursday after we come back. That would be too soon. So most likely the first test will be on the 15th, but it won't be on the 10th. So in the future, check your AUM Blackboard announcements and your email before every class. We don't want to miss any more classes. Now, the links that you need to purchase the ebook for the course have been on Blackboard for a while now. You need to get the textbook. The ebook is under $70, and the AUM produced workbook is under $20. Those are reasonable prices for textbooks. I don't think you would necessarily want to buy the brand new hardcover book, current edition. That's more than $200, which is pretty outrageous. But get the textbook. It turns out that the book that AUM uses for finite math and the book that we use for college algebra have identical first 5 chapters. And the entire content of the college algebra course is just in the first 5 chapters. So even the finite math book would work if you can get a cheap one, maybe even the, not the current edition, but the previous one. Now, your homeworks are coming in. I'm going to grade all your homework over the holiday weekend, and I'm planning on writing you individual emails pointing out how you did on those assignments. If you haven't turned them all in, one of them's not even due until tomorrow, but if you haven't turned them all in, and some of them are late, go ahead and turn them in. There will be a small penalty for lateness, but if, for example, if you submit an assignment that's a week late, I'm just going to count off, a perfect score is 20. I'd probably just count off 1 point, so you could still make 19, which is 95%. That's an A. It's important for you to do these assignments. Now, for the next couple of class meetings, we're not going to have any more graded homework. I couldn't get it back to you ahead of the first test. So it doesn't make a lot of sense to have more graded homework, but I am going to be sending you ungraded homework. So you'll have problems from the textbook, and also you should have a close look at the practice test for test 1 in the AUM workbook. Whatever you do, look at that practice test. It'll give you a good idea of what to expect on the first test. Okay, so let's introduce the next section of the book. I believe it's 2.2, if I remember right. So we know what a function is now. And in 2.2, we learn about some basic functions in their graphs. And okay, so what are these? Well, there's the identity function. And this is just y equals, it's sometimes written ID for identity. Usually a function name is just one letter, but you can have more than one letter. So the value of the identity function at x is just x. So the input and output are equal. Okay, so what would the graph look like? So when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. The graph is a line that goes through the origin and that has slope 1. So y-intercept is 0, slope is 1. Nothing to it. This does have the form mx plus b. We can write it as 1 times x plus 0, 1 times x plus 0. So this is the slope and this is the y-intercept. All right, well that was an easy function. So the next one is the squaring function. So y equals f of x equals x squared. Remember, this is function notation. We don't mean multiply f and x because f is not even a number. You couldn't multiply f and x. F is the name of the function. F of x means the function value when you put in the input number x. So for example, f of 2 is 2 squared, which is 4. F of minus 1 is minus 1 squared. Minus times minus is plus, so that would be 1. F of a half is a half squared. Now what is a half squared? Is it 1? No, it's not 1. A half times a half is a fourth, isn't it? Etc. So what does this graph look like? It's a parabola. F of 1 is 1, F of 2 is 4, F of a half is a fourth, F of negative 1 is 1, F of negative 2 is 4. So this function is, the domain of this function, by the way, is all numbers x. You can square any number. So here's the graph. There you are. All right, the next one is the cubing function. So y equals the cube of x times x times x. For instance, f of 2 is 2 cubed. That's 2 times 2 times 2, which is 8. F of negative 1 is negative 1 cubed. Negative 1 times negative 1 times negative 1. So minus times minus is plus. This part is 1, but then we have another factor of negative 1, so that would be minus 1. F of a half is a half times a half times a half, which is an eighth. Etc. What does that graph look like? Okay, f of 2 is 8, f of negative 1 is negative 1, f of negative 2 is negative 8, I didn't show that one, f of 0 is 0, f of 1 is 1, f of a half is an 8. It turns out that the graph looks like this. Okay, you remember how we number the quadrants, 1, 2, 3, 4. So this graph lives in quadrants 1 and 3. So for large values of x, the graph is quite steep. But for values of x close to 0, the graph is very shallow. Okay, and then we have the square root function. So f of x is the square root of x. We can also write that as x to the power of 1/2. And the domain is the set of numbers greater than or equal to 0 this time. So what are some function values here? So the square root of 1 is 1, the square root of 0 is 0, the square root of 4 is 2, the square root of 9 is 3, the square root of a fourth is a half, square root of negative 1, not defined, because we have a negative number here. Okay, so what does this graph look like? Well, it's half of a parabola, but it opens to the right rather than up. So we have the point 0, 0, point 1, 1, point 4, 2. 0.93 is over here somewhere. 1/4, 1/2. So this parabola is going sideways rather than up, and we only have half of a parabola. So for large values of x, the function is very shallow, but when we get to close to 0, the graph is quite steep. Okay, so the last one is the absolute value function. There are many others, but I'm just doing the 5 that are mentioned in our textbook. Y equals f of x equals x absolute value of x. The easiest way to describe it is the output value is the input value with its sign stripped off. So if you have a positive number, x, then y will equal that number. But if you have a negative number, the function strips off the negative sign. Examples, f of absolute value of 3 is 3. Absolute value of negative 2 is 2. Absolute value of negative a half is a half, etc. All right, what's this graph? It looks like this. So when x is positive, the graph is the same as the identity function, the first one we looked at. But when x is negative, we get these points. So the graph looks like a V, doesn't it? We have this is actually a right angle here. So this slope here is 1, this slope over here is negative 1. Okay, so this is a short introduction to section 2.2, which, by the way, is the last one that we'll cover that's going to be on the first test. There's material in 2.2 that I haven't covered yet. I'll try to do that tomorrow morning. And we have other stuff, loose ends in earlier sections that I may make another video. That won't be ready until the weekend. Thank you, class.